Hello everyone, I hope you all are good and you all are practicing problems. Let us for now focus on this question. What is given in here? We are provided with one cylindrical conductor and this is a thick cylindrical cell. Its inner radii is small r, outer one is capital R, its length is L. And it is given that when curved surface of cylinder are lagged, so when curved part of the cylinder is basically made insulator, in that case one end is maintained at temperature T1, another end at temperature T2, and in this case heat current which is flowing is H. Okay, so देखो this is a question of conduction. Conduction में heat transfer के लिए rate of heat flow को हम क्या लिखते हैं? फॉर्मूला होता है thermal conductivity into area of cross section through which current is flowing into temperature difference because of which current is flowing divided by length along which this heat current is flowing. ठीक है, अगर यहाँ पे सारी चीजें कांस्टेंट है for this direction of heat flow, then we can simply put things in the formula and get the answer. So dq by dt h given है, क्या यहाँ पे a l these things are constant? आप चेक कर लो, यहाँ पे l तो ये है, इस लेंथ के along करंट फ्लो कर रहा है. So at this point it started, from this point it started coming out, and throughout this length L, it is passing through this shaded cross section only. So everywhere cross section area is same. A is same. A is how much? A is equal to pi r ka square minus small r ka square. Done it? So this is this thing. K is constant. Obviously, this is material property. A is constant here. So this is constant, and that is why we can directly put in things in the formula and equate it to H, and this is L. Okay, so H is equal to this basically. Done it? Now in the second case, what is said, the two ends are lagged now we are making this insulator. So what we are doing is इसको हमने cover कर दिया, so it won't allow heat transfer to occur, and in this case what is happening, heat flow will occur along the radial direction. So यहाँ से हमने insulation cover को हटा दिया है. ठीक है, so देखो यहाँ पे inner wall होगा, and then these two are the inner wall, these two are the outer wall, and inner wall is maintained at temperature T1, it is said in the question, outer wall at T2, and then heat flow will occur across the radial direction. And we have to talk about what will be the value of heat flow in radial direction in this case. So how we can reach to this? क्या हम फॉर्मूला में पुट करके आंसर ले सकते हैं क्या? तो नहीं कर सकते. क्यों? क्योंकि देखो यहाँ पे a तुम्हारा जो है ना वो वेरिएबल हो जाएगा. कैसे? So just think here, as heat current is flowing along this length, at each point cross section area is not same. जैसे आप ऐसे सिलेंडर की बात करो and heat started flowing in this direction. I mean, when heat current has reached at this point cross section that it has to cover is curved surface area of this cylinder of radius, let's say small r or x. As heat current will move further outward, this x will increase. So curved surface area will increase. So cross section area through which current is flowing is always changing. A is a variable. Done है? For each small length total length इसके along flow किया है. But if you talk about dr length, then for this cross section area is different, and at each dr length cross section area is different. So we cannot simply put in the formula and say that heat flow will be particular value. Okay, so we need to do something. Let us talk about here delta t. We can write it like delta t divided by L by Ka. अब देखो करंट के फॉर्मूला को याद करो, हम क्या लिखते हैं, पोटेंशियल डिफरेंस बाय आर. सो डेल्टा टी बिहेव एज पोटेंशियल डिफरेंस, एल बाई के एज आर, क्योंकि आर को आप क्या लिखते हो, रो एल बाई ए. L length along which current flows, A cross section area into which current is entering or out of which it is coming out. Done, and rho is resistivity. So 1 by K, 1 by conductivity, right? So similar thing. So somehow if we are able to calculate what will be the resistance of this cylindrical conductor for radial flow of heat current, we can get the answer for heat current value. ठीक है, so चलो एक काम करते हैं. When let us talk about first solid cylinder here, and when heat current has reached at this point, how much resistance this red portion of cylinder of thickness dr will offer to the heat current. ठीक है, सो इसका रेजिस्टेंस क्या होगा अगर आप dr निकालना चाहते हो, देन इट्स लेंथ इज हाउ मच, नॉट दिस लेंथ आई एम टॉकिंग अबाउट, लेंथ ऑफ सिलेंडर की हम बात नहीं कर रहे, लेंथ along which current will flow for this red part of the cylinder. So for this dr, its thickness is dr, right? So dr length it will cross while crossing this red portion of the cylinder. So length के लिए आप क्या लिखोगे? You will be writing dr divided by k is a constant, area of cross section. So area of cross section for this you will be writing as pi r ka square. Done it? So this is this thing. Now, if we have to calculate what? If we have to calculate total resistance, we can do one thing. We can integrate it. So integrate it. Radius तुम्हारा क्या? Sorry, radius not resistance. It will be 1 by k pi is the constant. And sorry, मैंने curved surface area नहीं लिखा है, ऐसा pi r square नहीं होगा ना? This will become how much? 2 pi r into L. This is curved surface area. यानी कि area of cross section 2 pi RL. Done it? So what will be the constant? 2 pi KL. So 2 pi KL is the constant and this is dr by r. You will integrate it in order to get the answer. So integration you will do for solid cylinder from 0 to whatever is its radius. Let's say its radius is r naught. Then you will get the answer. But in this case, this is annular cylinder. Radius is varying from small r to capital R. So अगर आपको resistance निकालना है 1 by 2 pi KL and this is ln R, limit will vary from small r to capital R. So you will be writing 1 by 2 pi KL and this will become how much? ln R by small r. Now let us calculate heat current flowing in this case. So let us say that is H dash. So H dash will be temperature difference T1 minus T2 divided by resistance. So that will become 2 pi KL divided by ln R by R. अब देखो H के टर्म में इसको कैसे लिख सकते हैं? So H के लिए यहाँ पे आप ध्यान से देखो K pi T1 minus T2 can be written as how much? It can be written as HL by R square minus small r का square. ठीक है? So this is basically K pi this. So replace it with this one. This is K pi. Okay, T1 minus T2 that can be written as what? Then we will be left with 2L and this is H into uh, how much? HL divided by R square minus small r का square and then ln R by small r. ठीक है? So what will be the answer that you will be getting finally? This is your 2L square H divided by R square minus small r का square into ln R by small r. ठीक है? So this is what you will be getting. I hope you have understood this question, but if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.